So tprint works pretty much the exact same way that aprint works. The only difference between this and aprint is how the memory is allocated on the heap. The end result is you get a string that you can use throughout your program for whatever you need to use your string for. And you can see it's a very simple procedure. All you do is you pass in the things you want to be added into the string and you give it a separator value. Of course, just like all the other print functions in here, we have the formatted version and then the new line versions of the print function, in this case, the print function. But if you notice here, unlike aprint, which uses the context allocator, this still uses context, but it uses the context temporary allocator. And you cannot pass this into the procedure as a parameter. It's kind of already set up for you. Give you an example. If we go to aprint, you see one of the parameters up here is the actual allocator itself. And because this is one of the parameters, even though it has a default value, you can put whatever you want in there so long as it is a type of allocator. We can further see this by going into the actual implementation of tprint. If I go up to aprint here, we can see, again, we have the allocator parameter, and the allocator is being passed into the string builder, because just like aprint, just like tprint works just like aprint, where we have the string builders. But this time, we do not set the allocator ourselves. By default, in all of the tprint functions, the context.temporary allocator is forced into the string builder. You cannot change that whatsoever if you're using tprint. That is just the way it's set up. It's kind of like what I just said. You could actually edit this code here and change it however you want, but that would be probably a silly thing to do, to be changing the standard library. In a personal project, actually, no, mess around with however you want. But if you're working for a team of people, you probably wouldn't want to be messing around with the standard library. That would just cause confusion. But as you can see here, we have the temporary allocator forced upon us. So what does this mean? It means that the way the memory is freed is essentially the difference. So memory is still being allocated to the heap. It is still dynamic. It can grow and it can shrink, unlike if it was placed on this stack. But the way that we go about freeing that memory is a little bit different. For aprint, what we need to do, if we had 3 strings up here and they were all allocated using aprint, using the context.allocator, if we wanted to free this memory up later on, we would need to individually call the delete procedure and then pass in that string. So delete string 1, delete string 2, delete string 3. And that would eventually free up all the memory for us. Alternatively, we could like store these in an array, then loop through the array, but we'd still just be calling delete on all of the strings themselves. We'd just be doing it slightly different. However, Odin has something known as a memory arena. I've not looked into this to a great level of detail. I do not fully understand how the works under the hood, but my understanding of it is that memory arenas assume that all of the data being stored in them is somehow related to each other throughout your program. And when you get to a certain point in your program, you can just free that whole memory arena up. You can say, I'm done with all this information. We can free it from the heap and start using that memory for other things. So the benefits to this is if I had 3 strings and I've all allocated them using tprint, they are all going to the temporary allocator, which is a memory arena that comes with context struct. And they will all be stored on this inside of this memory arena. So if I want to free up the memory at any point in my program, all I have to do is make a call to the free all procedure and pass in the temporary allocator. All that memory is freed up for us. So the benefits of this is, 1, I believe we could actually lose all of the pointers to all of these memory addresses, and we'd still be able to free this memory. I'm pretty sure that's how that would work, because they're stored in the memory arena. I don't think you'd actually need the pointers themselves. And 2, on one call, all the memory gets freed. The downside to it is you can't individually be precise about it. You can't just say, oh, I only want this string to be freed right now. I'm fairly certain the way it's working is you either free everything or you free nothing. So you still have to put some thought into what you're allocating to a memory arena versus what you are allocating individually. And the example of this is a very quick one. It is just to show that, again, the tprint procedure, it works pretty much identical to aprint. We have the regular print version, which we can change the separator value around. We have the new line version of that, or we can have a formatted new line version. We also can print out the strings that we create. We could use them in other parts of our program, save them in files, whatever you can do with a string, you can do here because we are returning a string object. And then down here, if I wanted to free all of these, instead of having to go free temporary string 1, free temporary string 2, free temporary string 3, I can just make one call to the procedure that comes with everything in Odin. You don't have to include this. This procedure is always available to you. You just pass in the context.temporary allocator, because as we saw over here, the context.temporary allocator is what we are using to allocate this memory. So we have to pass in temporary allocator. This one in particular, first we can't create our own memory arena and then free it for tprint. You can make your own memory arenas, but it doesn't work like that for tprint. And then this will just free all of the information up. And one thing I did notice in my last video, when I freed the first string and then tried to print it again, I still got some information, because it just looked like the second string had been placed in place of where the first string was, so the first string still kind of pointed to the correct place. Or still kind of pointed to a valid memory address that had an array of bytes and some length it could read from. In this case, I'm going to do it right now, but nothing actually prints. I'm wondering if free all under the hood is making all of these strings be equal to null. So they still have a length attached to them, but I feel like the way they point is to nil or null in memory. So it's like that place in memory where it's like it doesn't exist. So if I run this program right now, we will see these 3 strings print. We will see the length of string, the first string, still exists, but nothing actually gets printed out down here. So that's just something worth noting that I discovered. So if you run this, there we go. We can see the strings prints. Free all has been called somewhere around here. So all of these strings have now had their memory freed. So there should be nothing in there really for the memory will probably still be there inside of the RAM. But if you notice, nothing actually gets printed out below. The string 1 still has its length, but when I try to print it out, or print string 2 and string 3, because they're being freed, they just print out nothing. So I think under the hood, when you do this free all in the temporary allocator, the pointers that they point to nil inside of Odin, so nothing actually comes out of them. And yeah, that's all I got to say on tprint. It's basically aprint, but we're using a temporary memory arena rather than a individual allocation.